Hey PCalc, this is part 2 of lesson 2 from section 2.1. We got a bunch of piecewise functions here. This is kind of a review of how to graph those and then check the limits using just a graphing approach. I'm going to show you a shortcut though that will be very, very cool, but I'm going to need you to still sketch the graphs because I think it's really important to have that down, the whole idea of I know the basic graphs and how to sketch them, so use the shortcut to check your answers to make sure your graphs are correct. So number 41. You got a parabola x squared minus 1. That just means it's a regular one shifted down 1 unit. So instead of the origin as its starting point, it's here. The shortcut to plot points is just to move right and then square how many units you went right. If there's a number in front of here, you'll have to multiply it at the end. But bottom line for x squared minus 1, moving right 1, you're going to plot a point up 1 squared units, which is 1. There's a partner point on the other side. Do the same thing again, go over 2 units. Now square 2. You'd go up 1, 2, 3, 4 units. On the other side, same thing with 3. You'd go 3 units to the right and then 9 units up because that's 3 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing over here. All right. Not my best graph, but certainly not my worst. That only exists when x is less than 1. So here's x equals 1. This would be one of those open circles because it's less than. All right, check out 4 minus x. This is going to be a linear function that has a starting point or a y-intercept of 4. 4. And this slope is actually negative 1, which is negative 1 over a positive 1 when you think about it as a rate of change, a rise over run. So you'd move down 1, right 1, down 1, right 1, down 1, right 1. And I'm going forever to the right because of the greater than or equal to. So it really doesn't exist at this spot. It starts at x equals 1 and then moves down like that. It's a closed circle up here because of the equal to. And now you can answer letters A, B, and C, what the limits are from the left, right, and at 1. So left of 1 basically is following the curve to that point. So the y value is 0. From the right, you're following this portion of the piecewise. You move all the way up to 3 units for the y value. And for C, the limit doesn't exist because they do not converge to a specific value. All right, let's check number 43 now. (43) gives us 2 linear functions. All right, one is the line y equals 3x minus 1. So that would have a starting point of minus 1 with a rate of change that moves up 1, 2, 3, right 1, or down 1, 2, 3, left 1. Down 1, 2, 3, left 1. I'm more concerned with the left endpoint behavior of this because it's less than or equal to 1. And I'm keeping it a closed circle because it is equal to. The other one starts at 3 on the y-axis, and then, again, has the same rate of change that we did here. So it's just going to move down 1 unit, right 1 unit. And only concerned with greater than 1 behavior. So here's x equals 1. Don't care about that. Now, it's an open circle, but there's already a closed circle there. So it's kind of like this. In the function family, somebody lives there. This one doesn't, but that part of the family does, if that makes sense. So it's, for all intents and purposes, a closed circle at x equals 1. All right, so from the left of 1, you equal 2 units. And same from the right. And then at that spot, the limit actually equals 2. Let's check down here. On number 45. 45 gives us a sort of like a three-pronged piecewise. Yeah, we got a parabola that's shifted up 1 unit to start with, only concerned with left of 1 behavior. So here's it shifted up 1, right 1, up 1, left 1, up 1, right 2, up 4. Not going to plot that point though. Going to plot this point. Less than 1. So that's an open circle at 1. And it creates that parabola shape going left. Now this is tricky. I know a lot of students get kind of like, what is going on here when you see f of x equals 1? F of x equals 1, I mean, think back to your Algebra 1 days. This is like the line y equals 1. That's a horizontal line that passes through the y-axis at 1 unit. So we're talking about a line that exists only at x equals 1. So you'd go plug in 1. You're going to get 1 as your y value. So it's like there's a closed point just kind of chilling out below that open circle here at y equals 1. Now the last one has a starting point of 1 on the y-axis, but we're only concerned with greater than 1 behavior. So if it starts at 1, it has a slope of 1 in front of the x, up 1, right 1. Now we can start up 1, right 1, up 1, right 1. And that's the function that's happening. So the question becomes, what's the limit as x approaches 1 from the left? Well, if you follow your curve, it settles at a y value of 2. We're not taking this as the limit as x approaches 1 from the left. We're taking the behavior, we're saying where is it approaching? It's trying so hard to get to 2, but it just didn't make it. So the behavior it's approaching is 2. And it's the same thing from the right. It's approaching a y value of 2 units. So when the limit from the left equals the limit from the right, the limit at that particular point, x equals 1, is supposed to be 2. And I think I said it on the previous video. The function's value at x equals 1 is equal to 1. That's what this dot does for us. It tells us what the function's actual value is at that point. All right, let's check out a word problem that uses some piecewise in there. Oh, before we do though, I will say this. It may not work totally for this one, like just visualizing this one's a harder one to do. But if you have something as clear-cut as number 43, what you can do to test the limits from the left and the right is say, this function, that function right there, if we are stuck less than or equal to 1, then left endpoint behavior is going to be informed by this part of the piecewise. This gives us our left hand limit. So for part A, when it says what's the limit as x approaches 1 from the left, you can just say it's 3 times 1 minus 1. There's no domain issue, so I can plug it straight in. It's 2. And what if we're looking for 3 from the right? Sorry, 1 from the right. Well, this one gives us the right-hand behavior. Because it's greater than. That's everything from the right of the function at x equals 1. So yeah, you just plug in 1. 3 minus 1 is 2. So make sure you have both of those approaches down where it's like, hey, if I had to draw a piecewise of relatively simple components, I could do it and then look at the graph and compute the limits. If I had to just say, find the limit with no graphing necessary, I could just plug straight in based on this domain. Okay, where did that go? Excuse me. All right, last one. I'll do 47 with you guys. Maybe 49 if I've got some time. I don't know. These videos don't have to be 15 minutes anymore. But let's check out 47. We'll try to keep it. We'll try to keep them concise. All right, everybody's favorite subject, taxes. It says a country taxes the first $20,000 of an individual's income at a rate of 15%, and everything over $20,000 is taxed at 20%. So find a piecewise defined function t for the total tax on an income of x dollars. So they're saying my function t, the amount of money I'm taxed, can be written as a piecewise. And it seems to be like this x dollars, $20,000 would be the spot where our domain would shift between less than 20,000 and greater than 20,000. In fact, the language that they use in here tells us which one's going to be equal to. It taxes the first $20,000, which means when you hit 20,000, you're stuck in that category of 15%. So we're going to say when you make less than or equal to $20,000, X dollars, the money you earn, is just going to be taxed at a rate of 15%. So here's what the piecewise is doing if you're in the under $20,000 category. Now this is kind of tricky when you move into the over $20,000 category. Because, say you make $50,000 a year. You are still going to be taxed in this bracket for the first $20,000. It's not until the second $30,000 gets accumulated that you're taxed at 20%. So here's what you got to do. You got to say, I'm going to get taxed for the first $20,000 at 15%. So I'm going to get taxed 15% of $20,000. You know that much for sure if you make over that much. And then we're adding on to it 20%, 0.20, of all the money above 20,000. So I can't just say X, because that's still talking about how much money I make. What I need to do is say, with that example of $50,000, how do I say it's 30,000 of the 50,000? Well, the difference is $20,000. You take the difference of how much you're making and you take away 20 grand. And now you've got the right variable expression to give that part of the piecewise. And this is going to be greater than $20,000 here. All right, sorry, I put this in the middle of the textbook example, but I think you guys can see it clear enough to where, this is if you are making less than or equal to $20,000. And if it's more, you were taxed at 15% here and 20% here, and I got to take away that $20,000. Otherwise, it's taxing me at 20% for the entire amount that I make. Now, 15% of 20,000 is actually just 3,000. So what we can do is we can clean this piecewise up a little bit. So my final answer for part A would be, it's going to be 15% times X if you don't quite make $20,000, and then $3,000 plus 0.20X minus 20,000. All right, part B basically just says, find the limit as X approaches 20,000 from both the left and the right. And at this point, it's like, oh, he gave us the shortcut. I don't have to graph that whole thing. This would be the left. So here's part B. Use the 0.15, which we already know at 15% of 20,000 is. We had to compute it earlier. It's 3,000. And then from the right, we plug in here. Now there's no domain issue, so I can do a straight plug-in. But look, if I plug in 20,000 here, all right, that's my limit I'm talking about. 20,000 minus 20,000 is 0. 0 times 0.20, 0. 0 plus 3,000, 0. And that's that. This is a pretty good stopping point, so I'm just going to end it there. Hopefully this was helpful. Thanks for watching.